Let's try to understand binomial distribution by means of a case study. So the problem is like this. Each operational loss independently is supposed to be insured with probability 60% in a BL. BL stands for a business line, so the probability of 60% arrived from historical data as numbers of insured losses divided by total number of losses in the business line over last 36 months. So what do we have? We have a business line. We have the data for the last 36 months. In that, what has been observed that for all the policies, if we take the ratio of insured by total losses, it is equal to 60%. So that's why we are saying that each operational loss independently is supposed to be insured with probability of 60% in a baseline. So this further implies that the annual number of insured loss is the sum of Bernoulli trial results and would follow a binomial distribution. So it will take individual losses, so they are kind of binomial trials, and we get to know whether it's insured or not. So altogether, it will form a binomial distribution. If during a particular year, 20 losses happen in the baseline, what is the probability that the bank would have insurance in 10 or less cases? So what it is saying that total losses is 20, and we have to find out the probability that the bank would have insurance in 10 or less cases. Is n is equal to 20, so there would be 20 Bernoulli trials. We have to find out the probability that x is equal to 10. So let's do it, and we have a sheet EX binomial and we have a file there. We will see the answer. But before that, let's do it in Excel. We have number of losses. This is the given quantity and this is equal to 20. Now we also have probability that losses are insured. This is equal to 60%. Now we have to find out the probability of number of insured losses is equal to 10. How do you do this? This is the question. We know the number of losses are 20 losses. We need to find out what is the probability that loss is equal to 0. So we will make use of a function, binomial, binom dist, and it requires the number, that probability that x is equal to x. Then it requires the total number of trials, which is equal to 20. So let's freeze it. Then it will require the probability of the event, that is the p-value, and we don't want the cumulative value, so we will set it to 0. Let's do it. This is nothing but the number of losses. This is nothing but n. This is nothing but p. We will also find out the mean. N into p. Variance, n into p into 1 minus p. This into 1 minus p. So now we know, given a binomial distribution and given parameters, and n and p, we know how to calculate mean and variance. Over here, we are calculating probability, and then we will calculate cumulative probability. We will do the same thing, binom dist. We have the number, we have the trials, we have the probability. We need to freeze the trial and probability. We need to freeze it, and then cumulative is run. So probability that the number of insured losses is 10. So what will that be? Let's find it for 10. So probability that number of insured losses is 10 is 11.71%. So let's copy it. So this is our answer. Now, going back to our slide, what is the probability of getting insurance benefit in 18 out of 20 cases? So we want in 10 or less cases, insured loss is 10, less than or equal to 10. We'll go to cumulative and 24. So the probability that we will have for the number of insured is less than 10 is 24.47, and the probability of number of insured losses is 10 is 11.71. Now the next question is, what is the exact probability of getting insurance benefit in 18 out of 20 cases? Let's go back. In 18 out of 20 cases, the exact benefit is 0.31%. This will be our second answer. So try to do whatever we did or saw over here. Try to redo that. And it will help you understanding the concepts of binomial distribution. This is very powerful and widely used. So having a good understanding of binomial distribution will help at work.